Okay, in this little video, I just want to show you how to use the calculator to find integrals. It's really easy. Okay, let me show you, give you an example here. How about this integral? Let's suppose we want to find the integral from 1 to 4 of cosine x dx. Okay, easy. What you do is click on Math, and then if you scroll up, you'll get down to the bottom, which is where you want to be. fn_int. fn_int is the integral function. Put in the function you want to integrate, cosine x. The variable you're integrating with is basically what that one is, dx, so we'll put an x there. We're going to start our integration at 1, that's the 1, and we're going to stop at 4. There's the 4. And there it is. There's the value of the integral, negative 1.5983. Easy, isn't it? Okay, let's try another one. How about this function? Let's do the integral of e to the negative x squared over 2 from 0 to 2. Now this one you can't actually integrate by hand. This one is very difficult to do by hand. So at least we've got the calculator to do it for us. Just math, fn_int. Okay, now we'll put the function in there. So let's do e, I got to find the e, there it is, e to the negative, use this negative down here, x squared over 2 with respect to x from 0 to 2. Click enter. Boom, there's your answer, 1.1963. Okay? Good. You can make your life easy if you do the following thing. Let me give you another integral. 0 to 1 of x squared plus 4x minus e to the negative x plus sine of 2x. Okay? Nasty looking formula. Put a dx there. So we've got a really ugly little formula there, and you know it's very likely that if we just type all that in the calculator we're going to make a mistake. So what I like to do is I like to put the function in the function plotter first. Okay, x squared plus 4x minus e, where's e, to the x plus sine 2x. Okay, now I'm going to put the function in there. Let me get rid of that extra parentheses. Okay, good. So now my function's in y1. So when I do my integral now, all I really need to integrate is y1. I don't have to plug the function in. Vars y_vars function y1. So this takes the place of that ugly old formula. With respect to x from 0 to 1. Boom, there's my answer. Now, suppose we need to change that. Oh, oops, I really didn't mean 2x, I meant 3x. If I typed it in here, I'd have to retype the entire thing or do second enter, and I might have, messed up or done a lot of other computations in the meantime. All I really need to do now is just go back to y equals, or back to the function plotter, change my function to what it is, what I want it to be now, click second entry, and do it again. Okay, so it makes life easy, and then when you've got really, really complicated formulas, what I like to do is do each section of the formula in each of these and then combine them all together. So probably won't have a whole lot of opportunity to use that, but if you're good with the calculator, you can see how that would help out. So there's the calculator stuff on integrals. Now let's take a look at the calculator stuff with derivatives. I showed you this the other day. It was about a week and a half ago now. So we're going to go ahead and let me erase those and let's do some derivatives now. So let's get out of this, clear that up. Let's suppose that I want to take the derivative of, some really nasty old function. Let's say sine of e to the 4x cubed plus cosine x. There, nasty enough for you? And let's suppose we want to evaluate this when x is equal to 1. Okay, no problem. What we do is plug that in here this way. Click Math. Go down to the bottom again. This time do n-deriv. And now let's plug in the formula. The function is sine of e to the 4x cubed plus cosine of x. Okay? So let's see. That closes that parentheses. E to the 4x, so that closes the parentheses on the e. That closes the parentheses on the sine. Okay? Does that make sense? Okay, good. Comma. With respect to x, we're going to take the derivative with respect to x at x equals 1. And that's what our function looks like. And if we click enter, it's going to evaluate it and tell us the derivative is equal to 750.2074. Very slick, very easy way to do things. And this one would be a good candidate to break up my functions in the function plotter instead. I could do the 4x cubed plus cosine x. I could call that y1. Then I could do sine of e to y1. This would be y2 equals sine of e to the y1, like that. Okay, and then I would take the derivative of y2 with respect to x. So, there you go, a little bit on how to do this with the calculator.